Hey there, it's Shannon Magic Myers, and today we're going to look at this Bale ejector problem. I think what you're going to find is that the trick is at the end when you're finding your angle. It's a little bit tricky because it'll be a double angle. But anyway, we'll do the whole thing. Bale ejector consists of two variable speed belts at the end of a baler. Its purpose is to toss bales into a trailing wagon. So in loading the back of a wagon, a bale must be thrown to a position 8 feet above and 16 feet behind the ejector. So anyway, I got out a picture of an ejector. It's not, to scale, but this is the idea. The bale goes from that ejector up, and then it's going to end up continuing it to go down at some point, like that. Sorry, it wasn't drawn very well on the end. So let's do this. We've got our projectile motion model in feet, right? It says we're in feet, so it'll be R, the vector R at t is equal to quantity V cosine theta times t, and that's going to be times I, plus you've got your V sine theta times t minus 16 t squared, and then that whole thing will be multiplied to j. Now, we need to take a look at what we have. So 8 feet above, 16 feet behind gives us that position of 16.8. And so 16 is going to equal to V cosine theta times t. If I isolate t, I'll get 16 over V cosine theta. And then on the other side here, we have 8 is equal to V sine theta times t minus 16 t squared. So if I plug in what I got for t over here, I'll end up with 8 equals V sine theta times t, which was 16 over V cosine theta, and then minus 16 times t squared. So you'll have 16 over V cosine theta, the quantity squared. Okay, so we will get 8 equals 16V sine theta over V cosine theta, and those V's will divide out, and then minus 4096 over V squared cosine squared theta. So then dividing by 8, we'll get 1 is equal to 2 sine theta over cosine theta. For now, I'm just going to keep everything in terms of sines and cosines. And then this will be minus 512 over V squared cosine squared theta. Now we want the 512 over V squared cosine squared theta. I'll get it on the left. And then we'll have our 2 sine theta over cosine theta minus 1 on the right. And multiplying both sides by cosine squared theta over 512 to isolate the V squared term. We will have 1 over V squared equals 2 sine theta, one of the cosine thetas divides out, so we'll just have cosine theta, and then minus cosine squared theta. All of it's going to be over 512 because they were both being multiplied by 512 in that denominator. And then flipping to get b squared on top, we will have 512 over 2 sine theta cosine theta minus cosine squared theta. Now I'm going to write this as a function of theta, and we'll move on to the whole optimization, or we want to get the derivative to minimize. So we're going to find the critical numbers. So first we'll write f of theta. F of theta is going to be equal to that right-hand side. And I'll write it as 512 times the quantity, 2 times sine theta cosine theta minus cosine squared theta to the negative 1. F prime at theta will be 512 times negative 2 sine theta cosine theta minus cosine squared theta to the negative 2 using that power rule, and then using the chain rule we're going to have times this portion of it will have 2 sine theta, and then differentiating the cosine theta we'll get negative sine theta, and then add to that we'll have 2 cosine theta, differentiating that part. Sorry. Actually, we don't need parentheses right there. So 2 cosine theta, and then we'll have times cosine theta. Now, the second portion, we've got to differentiate this guy. So then we will have minus 2 cosine theta, and then times negative sine theta, and that finishes off our derivative. But of course we want to clean that up a little. So f prime at theta will be, so this portion of it here, if you notice, if you factor out the 2 and write it as cosine squared theta minus sine squared theta, that's a double angle identity, cosine 2 theta. And then this guy over here, including that 2 in there, we're going to end up, and that negative will be out front, we're going to end up with a plus sine 2 theta. So writing this in here, we'll have 512 times 2 cosine 2 theta plus sine 2 theta all over, and let's see, we'll have a negative sign here, and then we'll have 2 sine theta cosine theta minus cosine squared theta squared. Now we need the zeros, so we're going to set f prime at theta equal to 0, and then we'll have negative 512, we just equate it to that numerator, times 2 cosine 2 theta plus sine 2 theta, Well, dividing out that negative 512, we'll get 0 is 2 cosine 2 theta plus sine 2 theta. And negative sine 2 theta will be equal to 2 cosine 2 theta. And dividing both sides by cosine 2 theta and swapping that negative, we'll have sine 2 theta over cosine 2 theta is equal to negative 2. So now this is going to be equivalent to tangent 2 theta is equal to negative 2. And on the graphing calculator, you got to be careful because we want this to be, that negative output is going to give us an output when we do the inverse tangent of negative 2. It's going to put us in quadrant 4. And so we are going to have to, instead of adding 180 like we normally would with a single angle, we've got a double angle. So we're going to have to cut our results in half and then add plus 180 divided by 2 because we're in degrees. We'll just be adding 90 degrees. So here we go. Tangent at clear. Inverse tangent at negative 2 equals, we get this result. We have to divide that result by 2 because it's a double angle. And then we have to add to that result 180 divided by 2. And we get 58.28 degrees. And that was honestly probably the trickiest part of one of the trickiest parts of the problem. All right, so this one is going to be theta is approximately, 0.28 degrees. And then now the next part is substituting into the equation for v because we wanted to get the speed. All right, so now remember we had our original f of theta, right? But what was f of theta? F of theta was v squared, right? So we want to find v. We're going to be using this equation here. So we had v squared was equal to 512 over 2 sine theta cosine theta, 2 sine 58.28 degrees, and I think it was minus cosine squared theta, so minus cosine of 58.28 degrees, the quantity squared. So v squared, go back to the calculator, is going to be 512 divided by quantity. 2 times sine 58.28 and then times cosine 58.28 into parentheses, and then minus cosine 58.28 parentheses, and you know what? I'm just going to do times cosine again. I should have put an extra grouping symbol. Cosine 58.28 degrees, and then end our parentheses. That gives me cosine squared. Enter. And so we will get 828.4334, and then we need to find the square root. and you get approximately 28.78. And let's look at our unit. You can put plus or minus, but you're in speed. So we're just going to put our V. Our V was 28.78, and that is going to be in feet per second, I believe. Yes. So this is one result. This is another result. And then I think there's also a part B of the problem. So for part B of the problem, the ejector has a fixed angle of 45 degrees. Find the initial speed V required. So let's check it out. So here we go. If theta is 45 degrees, we would have 16 is equal to V cosine theta times t, same kind of problem, but we have the angle, right? So 16, plugging in the angle, we'd have V times cosine 45 degrees times t. So 16 would be V times root 2 over 2 times t. I'll write it like this. And then we would have 8 is equal to V sine theta, that quantity times t, minus 16 t squared. And then 8 would be, similarly, I'll just write it, V times sine at 45 degrees times t minus 16 t squared. So we would get 8 is equal to V times root 2 over 2 times t minus t squared. So we know that from our first part, we'll take advantage of the work in that first part. We're going to use this general equation here. The V squared is 512 over all that, the circled one. So go back down here. V squared is 512 over 2 sine theta cosine theta minus cosine squared theta. So V squared would be 512 over 2. We already figured all that out because we're at 45 degrees, right? Theta is 45 degrees. So we'll have 2 times root 2 over 2 times root 2 over 2 minus root 2 over 2, the quantity squared. So V squared will be 512 over, so root 2 times root 2 is just 2. 2 times 2 is 4. So we'll have 2 times 2 over 4 minus 2 over 4, which is basically 1 minus a half. So V squared is equal to 512 over 1/2. The V squared is going to be 1,024 So it turns out that V, let's do that on the calculator, is 32, and that'll be 32 feet per second. Groovy? All right, perfect. I think that is all that the problem asks for. So if you enjoyed this show, please subscribe and click on that like symbol. And I hope you have a wonderful morning, afternoon, or evening. Whenever you're watching this video, have a fabulous day. Bye.